Okay, so we're going to prove that 0.99999, right, forever is equal to 1. And we're going to do this by using the infinite geometric series. So in case you might have forgotten the infinite geometric series, the infinite geometric series goes as follows. We know that the series from 1 to infinity of a sub 1 times r to the I minus 1, right? So this is, of course, equal to a sub 1, because if we plug in 1 here, it's going to be r to the 0, which a sub 1 times r to the 0 is just a sub 1, plus the next one would be a sub 1 times r, because it would be 2 minus 1 here, so that would just be 1, and it would be a sub 1 times r. The next term would be 3, so 3 minus 1 is 2, so it would be a sub 1 r squared. The fourth term would be a sub 1 r cubed, and so on forever, right? And we know this infinite series is equal to a sub 1 over 1 minus r. But this is only true whenever we have the absolute value of r is less than 1. Okay? So this only happens when the absolute value of r is less than 1. So now let's investigate what this 0.99999 is, right? So 0.9999 repeated, well, we know this is equal to 9 over 10, which is this piece here, plus 9 over 100, which is this piece here, right? The 100th place, plus 9 over 1000, the thousandths place, plus 9 over the 10,000ths place, right? And so on, right? Well, we want to fit it into this form here. So we know our a sub 1 is going to be 9 over 10, right? So we're going to have to rewrite this as 9 over 10 plus 9 over 10. And we can rewrite this as 1 over 10, right? Because 9 over 10 times 1 over 10 is 9 over 100. Multiply straight across. Plus 9 over 10 times 1 over 100, right? That's this one here, plus 9 over 10 times 1 over 1000, right? And then plus forever and ever, right? So we have our a sub 1 in all of these slots, just like up here. But now we have to find our common ratio. And it looks like our common ratio is going to be 1 over 10, right? Because the second term has that r. So luckily, we can write all of these in terms of r squared, and r cubed when we know r is 1 over 10, right? So this is equal to 9 over 10 plus 9 over 10 times 1 over 10 plus 9 over 10 times 1 over 10 squared, right? Because 1 over 10 times 1 over 10 is 1 over 100, plus 9 over 10 times 1 over 10 cubed, right? Because 1 over 10 times 1 over 10 times 1 over 10 is 1 over 1000, right? And then the sum goes on and on. So you can see we have it in the form of our infinite series, right? So we know that this is equal to the sum from 1 to infinity of 9 over 10, right, times 1 over 10 to the I minus 1, right? The first term, when I is 1, it'll be 0 for 1 over 10, so we'll just have 9 over 10 in the first one. For the second term, it's going to be 9 over 10 times 1 over 10 to the 2 minus 1, which would be 9 over 10 times 1 over 10, and so on, right? So we know that this is the same thing as this. And we have r, right? We have r, which is the absolute value of 1 over 10, is, of course, less than 1. So we know all the conditions are met for the infinite geometric series, right? So now we know that 0.9999 is equal to the infinite series from 1 to infinity of 9 over 10 times 1 over 10 to the I minus 1, which we know this is equal to 9 over 10 over 1 minus 1 over 10, right? And then, of course, this is equal to 9 over 10 over, and then 1 minus 1 over 10 is 9 over 10 again. And of course, anything over itself is 1. So, using the infinite geometric series, we got 0.9999 is in fact equal to 1, which is a pretty cool result.